Cool. Just learned the keyboard shortcut of recording. All right, I'm gonna go ahead and unmute everybody. All right, y'all, how y'all doing? Well, let me let Dimitri in. Hey, so while y'all working on this a little bit, a couple things just to discuss, and that is I'm gonna get a connection to a second monitor. I think it's gonna show up today, so I'll have a second monitor this, because right now I got all these windows on here, so it's a little cumbersome. So once I do that, I might be able to integrate video more. So that way we can all see each other and I can call on people. Y'all can, anyway, just that'll probably start Thursday. I'll see what we're going to do about that. The 2 sessions we have a week consist of a warm-up and homework. So we're going to have 2 sessions, 2 warm-ups, 2 homeworks every week. And so all you have to do is take a picture of the warm-up, take a picture of the homework, send it to me on Gmail, just making sure everyone got the message. So, okay, so warm-ups, homeworks, twice a week, send it to me on Gmail, and then I'll get it. That's a C, if that's what you do. That's it. And there's going to be 2 assessments, okay? And speaking with Mr. Walker, this is what I came up with. So I'm going to put y'all in different email groups, okay? And then on the day of the assessment, which is just going to be like a quiz, I will send to the email groups the quizzes that those groups will take, okay? And then you'll have an hour to send it back to me. Now, I don't anticipate the quizzes taking more than a half hour. And so, I'm not going to be precise. So if you're like 5 minutes after, I won't worry about it. But that's about the best way I can think to do this. Okay. So anybody got any questions about anything right now? We're good. All right, let's go over this warm-up. So this is similar to the warm-up we did, I think, last week. But this time, not only are we looking for the domain, we're also looking for the range. Okay, and that can be kind of tricky, but there is something that's really cool about inverses that we're going to see when we do this, about how we can find the range a lot easier without even have to think about it. All right, so I'm going to go ahead and stop the share. All right, let me get my phone ready. And so we're going to look at that first problem right there, which would be the cosine. Okay. Now, just to go over stuff, so this would be the amplitude, the 5. So it's going to go between 5 and -5. We didn't add anything to this, so there's no vertical displacement. This would be the frequency, the K. So in other words, we're going to have 2 cycles from 0 to 2 pi. Okay, and then here, that's not necessarily a phase shift because we'd have to factor out the 2. So if we factored out the 2 here, that would become pi over 6. So again, just reviewing how to make this graph. Let me let Pierce in. Oh, this would be so nice when I have that second monitor. Yeah. So what was that saying? What was I? Let me hit something up here. Okay, never mind. So here, notice that the K is 2, and when this equals 0, it's pi over 6. So the phase shift is pi over 6. What's the period? We divide 2 pi by the 2. So we're going to go from 0 to pi, and then from pi to 2 pi. So that's why 2 is called the frequency. All right, so just to remind y'all again, so 1, 2, 3, 4, 5. So this would be pi over 6. 1 pi later would be 7 pi over 6. Right, and so 5, -5. So start here. So that's the graph. Right, so the range we know is from 5 to -5. The domain would be all real numbers. Again, the domain is based upon the x here being radians. And so there's any possible numerical value we could substitute, right? It's going to go forever left and right. All right, so automatically we now can write the domain. x would consist of all real numbers, and the range, y, such that, and I'm not going to write the brackets just to make this simple, y is going to be between -5 and 5. So I didn't put the braces just to make that less cumbersome, given that, you know, how we're getting this is different. But you should put braces there if you want to be technically correct. Okay? Well, let's go ahead and find this inverse. All right? And so here, just like before, we make this a y. Okay, and then we're going to go ahead and divide by 5. All right, now we want to go ahead and reverse the function. So again, we can't divide by COS. That's function notation. It's just got 3 letters. So we want to reverse the function. We want to switch the input and output. So we want this to be the output, and we want that to be the input. So we take the cosine inverse of the other side. Right, and then we get this. Right, and here, depending on how you want to handle this, do you want to multiply by 3 to everything? Do you want to add pi over 3 and then multiply 1/2? However you want to go about that, at some point you will get to, let's see, pi over 6 plus 1/2 cosine inverse. And then I'm just going to switch the y to an x. And then this would have been the inverse of the original function. Now, I like to use brackets here, just because that -1 symbol is a little cumbersome. Remember, this means the inverse function. Okay. Well, remember the difference between the inputs here. In the original function, the input was radians, right? This is the reverse. That is the ratio. Right? So this is going to give you all the possible angles, or maybe just one, right? And then you would use that to construct the other ones based upon the ratios. And so this has to be between -1 and 1. So we would solve that problem. And notice that's -5 to 5. Well, wait a minute. We already had that up here, right? Okay, and notice now the x from the inverse is the y from the function, because the range and domain switch when you switch the x and y. You're switching the roles of the independent and dependent variable, and so now that's why these are related. So the domain here of the inverse is related to the range of the function. So x such that, okay, and again, I'm not using the braces just to make that less cumbersome visually. Okay, and then the range of the inverse is related to the domain of the function, because we could get back any possible radian measurement when we do the calculation. All right, so y, oh, I'll just say y real numbers. All right, so here's the thing. You can get the ranges by just using the domain of the other function. So if you want the range of the function, that's going to be related to the domain of the inverse. If you want the range of the inverse, that's going to be related to the domain of the function. And that's very helpful, especially when you have functions that are a little bit tricky. I mean, this is a little easier, right? We don't have a vertical displacement. And so when we switch x and y, this y becomes x, and that's why we have right there. All right, let me see if anybody said anything. Sorry. Everybody good? Okay, so we've got 2 more. And again, the point here is to go over how to find these inverses and also find the range, using the idea that the range of the inverse comes from the domain of the function, and the range of the function comes from the domain of the inverse, right? So now we're going to look at the next one, which I think was a rational function. Yeah, so the next one, which would be that one, right? So 2x minus 7 over 4 plus 5x. All right, so that's our function b, 2x minus 7 over 4 plus 5x. All right, now this is a rational function. Okay, so remember that if we want to get the vertical and horizontal asymptotes, we could sketch this graph. All right, so sketching this graph. Okay, well, when we got to 0, that's the vertical asymptote. Notice you would solve minus 4 divided by 5. So that's over here. And remember, the horizontal asymptote comes from the ratio of the coefficients that come from the largest terms, 2x, 5x, so 2/5. Right? And when we get the y-intercept, we're going to get negative 7 over 4, which is this one. And so we can sketch this graph, and that's going to be the graph. Just by knowing the y-intercept and the horizontal and vertical asymptotes. Very helpful. Okay, so notice the domain here is based upon the vertical asymptote. X cannot be negative 4/5. So the domain of this function, x cannot be, well, just to be more formal, x such that x cannot be negative 4/5. Now, again, we're assuming real numbers, but if you don't want to make that assumption, then you can just state it right here. And again, I'm not putting the braces here just because it's a little cumbersome visually, but I did it there. There you go. Okay. Now the range, notice the range is related to the horizontal asymptote. So we're going to get every possible y above and below except at the horizontal asymptote, which was 2/5. So the range would be the y's such that y cannot equal 2/5. All right. And again, we can assume real numbers, but if you don't want to make that assumption, then this is where you would do that. Okay. All right, let's go ahead and find the inverse. So again, we put this as a y. Go ahead and multiply, cross multiply. So 4y plus 5xy equals 2x minus 7. So we're solving for x because we want the x to become the output, the dependent variable. Okay, so we want to get x on the same side, right? So I'm going to do a switcheroo, right? Add 7 to both sides, subtract 5xy. Okay, now we want to, again, we're solving for x because we want x to become dependent, the output variable. So now we want to factor out dx. Okay, and so now we go ahead and divide, and I'm going to skip a step. I'm going to go ahead and switch the x and write the function notation. So this is going to become 4x plus 7, and that's going to become 2 minus 5x. And since this came from the b function, we write the same letter, put the little negative 1. And so that's the inverse. And again, the reason we want the input variable to be the same for both inverse and function, that way we can compare them with the same variable. All right, well, this is also a rational function. Now, we could graph this and do the same thing we did with the function, or we could take the shortcut, which I'll point out in a second, how that relates to the graph. So the domain of the inverse comes from the range of the function. So this was 2/5, can't be 2/5, so x can't be 2/5. Right, and then the range of the inverse comes from the domain of the function. So this was negative 4/5, so the y can't be negative 4/5. All right, now remember where that comes from. The domain came from division by 0. Notice when you put 2 minus 5x equals 0, you get 2/5. 2/5. And the range came from the horizontal asymptote, and that came from the numerator and denominators coefficients of the largest terms. So 4 over negative 5x, 4x over negative 5x, negative 4/5. Right? It's cool, huh? It's related to the graph. It's also related to the function, which is a lot quicker. Okay? Now, in this case, we could get the range. because we know something about this function, but sometimes we can't. So sometimes we'd have to get the inverses domain and use that to get the function's range, and the function's domain and use that to get the inverses range. That's how this is helpful, because sometimes the ranges are troubling, right? With the domain, we can just calculate. Oh, it can't equal 0, so we solve a problem. It can't equal 0. We can do something like that. Range, we can't exactly do it that way. Okay, everybody all right? Here, we got one more. All right, so then the last one was the quadratic, and so this is where we're going to solve and put into vertex form. So 4x squared plus 12x minus 5. Okay. All right, well, this is a quadratic, and we could kind of graph it too. So we could get the vertex. I'm just going to go ahead and skip that just to save a little time here. So let's just go ahead and get the inverse. All right, so I'm going to change this to a y, then I'm going to add 5. So I skipped the step here. Now, some of us might like to factor out our 4. Okay, I'm going to go ahead and divide by 4. I think that's a little easier. Okay, and then this is the part we want to complete the square, right? So we want to base this on half the b value. So this is what we're trying to create, right? And so what do we have to add here? Well, 3 over 2 times 3 over 2. All right, so 3 over 2 times 3 over 2 is 3 over 2 squared. So we add that there, and we add that over here. Okay, and then notice what happens. This is basically what we get. All right, so when this equals 0, that would be negative 3 over 2. That's x at the vertex. Remember negative b over 2a? Negative 12 over 2 times 4. Negative 12 over 8. Negative 3 over 2 when you simplify it. So notice we can get the vertex x here, or we can use negative b over 2a to get it. All right? And so when we simplify all that, this is basically a common denominator already, so that's good. All right, and then we're going to take the square root, and then we're going to subtract 3 over 2. So I'm doing a couple extra steps here. Don't forget the plus or minus. Okay, 9 plus 5 is 14. And again, I'm switching to the x. And then this would be the inverse. Oh, stupid. Y'all, I made a mistake. I just realized it. Wait, no, maybe I didn't. Let me double check. No, I didn't. I did on my notes. Okay, so I made a mistake on my notes, but I didn't make a mistake when I gave y'all. Yay! All right, because on my notes, I put that as minus 5. But we should be adding 5 to both sides, so this is correct. Okay, now notice something here. We already know the x at the vertex of the function's negative 3 over 2. In the inverse, this has to be greater than 0. Notice when this equals 0, you get negative 14. That means this parabola, which we knew was open up, has a vertex at negative 3 over 2, negative 14. All right, so there's all kinds of ways of getting the vertex. Now, we already knew with the function that the domain was all real numbers. Once we get the vertex, we know the range is going to be greater than or equal to negative 14. So the domain of the function would be x, remember, all real numbers, whereas the range will be the y is greater than or equal to negative 14. Okay, and again, I'm not using the braces just to make that less visually demanding. Okay, now remember, we can do the inverse by applying some equations to the domain issue here, which that has to be greater than or equal to 0, right? So negative 14 greater than or equal to negative 14, right? Notice we get that from the range of the function. So the domain of the inverse related to the domain of the function, or you could put x plus 14 over 4 greater than or equal to 0. Either way, you'll find the same thing. Now, it's a lot easier to use the domain and range of the function. And then the range would be the reverse of that. Since here, notice we're plus or minusing any number to the negative 3 over 2. This could be all real numbers. The same thing here, the domain of the functions related to the range of the inverse. So y is related to all real numbers. Boy, that was fun. No, that's not facetious. All right, anybody need anything? Okay, so let's go ahead and look at the homework. No, give me a second. What am I doing? Okay, so I don't know if this helps with y'all, but any particular problem you want me to go over? So I might jump around a little bit. Wait patiently. Any particular one anybody wants me to go over?
Yeah.
8, 19, 21. Okay. So verbally or chat, text.
Mr. Napoli, I just had a question. Like after looking at your notes, I was wondering, how do you know if it's annual the annual rate or like the rate per period?
Okay, well, it'll tell you. It'll say compounded. So when you're talking about problems after 14,
Okay.
after 14, okay, I'll assume. So let's see, share screen. Go to here. So notice it says compounded monthly. So that means you're dividing the 14% by 12. You always assume these percents are per year unless it says per something else. So this is
okay.
all right. So this is literally saying it's 10% per year. Okay. Oh, sorry about that. I meant to touch another screen. So sorry about that. Yeah, I thought it was compounded monthly. So this means it's 10% per year compounded monthly. So you got to get the per month percentage by dividing by 12.
Okay, that was my problem. I assumed it was the 10% per month rather than per year.
That's understandable. Yeah.
Yeah. Thank you.
You're welcome. Okay, so let me. What's that?
Do 7 through 14.
7 through 14. Okay, I will. Let me get my screens back. 7 through 14. Okay, so I'll go with 7 14. Then I'll jump to 19 and 20. Okay, so 7 through 14. Now, this part here is basically telling you to determine either what the annual percentage would be, which is what they're asking for in 11 through 14. And in 7 through 10, they're asking you, what's the percent per compounding period? And what they give you is the percent per year. All right, so this 12% is per year. What's it per month? Divide 12% by 12, you get 1%.
What?
Okay, this 11% here for number 8, that's per year. We want it per quarter. That's what compounded quarterly means. All right, so the interest rate per compounding period, the interest rate per quarter. So divide 11 by 4, you get 2.25 or maybe 2.75. Here, this is 7% per year. What is it semi-annually, half a year? Divide by 2, 3.5. 9% per year, what's it annually? Well, that's already annual, so 9%.
So that percentage number was meant to refer to the annual amount. Because it said the annual and compounding period are given And I was trying to figure out where they gave you the annual period as like
Ah,
where.
yeah. The way that's worded. No, yeah, this does not mean the annual period.
Okay.
The way that's worded, yeah, that makes sense. It's saying the annual, and it's just implied the annual percentage. It didn't say
Yeah,
that.
I did not understand that. That's
Yeah.
clear.
Is that clear for you, Tori?
Yeah, I was like, did he take a picture of it? Or am I missing something here?
Yeah, I understand. Yeah, I mean, this is convoluted language, you know.
Thank you.
Yeah, no problem. So then the next part, they're giving you the rate per compounding period. What would the annual be? So this 0.01, 1% is per month. To get it per year, multiply 12. So 12% per year. So 7 and 11 are basically reverse of each other. Okay, and then 12 is per half year. So you'd multiply by 2 to get it for the full year, 5%. 8% per year, well, it's already annual. 2.25% per quarter. So we need it per year. We multiply this by 4. So 9% per year. Okay, and then y'all wanted 19 and 21. So 19, you're borrowing 800. Okay, and so you're going to use the formula, the amount equals the proportion, and then 1 plus whatever the interest rate per year is divided by the number of times per year. All right, so 800, I'll show you all this in a second. 1 plus, okay, and then we have for 19 the 12%, so that's going to be the 0.12, and we're compounding that daily, so we make that 365. Okay, and so this is now what we have. But the time we're doing this is 200 days. This is a growth factor per day, so the exponent is days. And so we put 200 up there. So that's 19. So again, whatever the time period is based on, once you divide the yearly by 365, it's now days. So the exponent's got to be the number of days.
Mr. Napoli,
Mm-hmm.
why would you not use the other equation where it's 1 plus r?
Okay, well, this is the R. That's the rate per day.
Right.
This fraction is the R. As opposed
Isn't I supposed to be the APR or annual rate per year?
Yeah, the I is generally the annual rate per year.
So then is 12% the rate per day or the
12% is per year.
Okay.
That's why we divided by 365, because we needed this to be per day since we're compounding daily.
Okay.
Okay?
Thank you.
Yeah, you're welcome. There's little subtle things here. You know, these letters, they get used interchangeably. It's just how it is. Okay, so then 21, let me share screen. All right, 21. So this time, what we want to do is figure out what the principal is. So we want this to equal 100. Okay, and we're going to find the P. And so here, we're doing this in 6 months. The 10% per year is being compounded monthly. So we add the 0.10 divided by 12. Okay, and we're doing this for 6 months. All right, so this is how we set that up. Now, once we divide the per year by 12, this is now a monthly growth factor. Okay, and so this is now a monthly growth factor. So the exponent is months, which they told us was 6. Okay, so this is where you divide the 100 by that quantity, which if you want me to do it real quick. So let's say, so I'll go 0.10 divided by 12, and then I add the 1. All right, so, right. Okay, now we want to raise that to the 6th power. Okay, so then that's what's multiplied to the P. And then we divide. So we're going to divide by 1.05105. Right, so we have something like this. And I'm just abbreviating it right there, right? So then you would divide. So you'd wind up with 100 divided by that. Oh, darn it. Sorry, y'all. Let me delete that. Delete. So 100 divided by previous. So you should get $95.14. right? Okay. Is there anything else anybody needs?
25 didn't give us enough information to solve, right?
Correct. Yeah. So you couldn't
Okay.
do 25. They got cut off. That's no big deal. It's not like you had enough problems, right? But yeah, don't worry about 25. Now I set all these up for y'all. Just, you can see. And the only thing down here is 37 was a little tricky because of the way they gave it to you, right? So 37, they wanted you to find out the new balance based upon the per year 1.5% compounded quarterly. So you got to divide that by 4. But they're giving you the time period in months, not quarters, right? Well, a quarter of a year is every 3 months, right? 12 divided by 4. So when you divide this by 3, you find out how many quarters that is. All right, maybe you guys knew that, but I know that sometimes can be an issue. So that's why that's 6, 18 divided by 3. We got to do that because this is based upon quarters. This growth factor is on quarters, so the exponent's got to be quarters. You can't put 18 up there. 18 divided by 3. Okay?
Can you do 44 and 45?
44 and 45? Yeah, sure thing, Tori. So 44 and 45 are basically a similar problem. So they want you to find the interest you would get, simple interest, and then compound interest, and then they qualified the compound interest. Both of these are over 2 years, and they're the same. The only difference is for 45, they just changed the percentages. Okay? So for the problems, the percent for the simple interest, I'm sorry, y'all, I'm moving my screens around. So the simple interest is 12%, and the compound is 10%. It's done monthly, and both of these are over 2 years. Whereas for 45, the only difference is simple interest goes from 12 to 15, and compound goes from 10 to 14, and instead of monthly, it's daily. Okay, so then that's why you see the setup here for those 2 problems. So here's the interest for the simple interest, the 1,000 times the 0.12 times the 2. Compound interest, 1,000, we create our growth factor per month, so the 10% divided by 12. In 2 years, that's 2 times 12 months. The reason we're subtracting 1,000 because we want to find the interest. How much more over 1,000? And down here, the only difference is instead of 12, 15, over when the compound 14%, now it's daily, so that's why we're dividing by 365. And since we're doing this over 2 years, the exponent would be 2 times 365. Okay, and again, we're subtracting 1,000 because we just want to find the interest. How much over 1,000? Okay, so does that help? Is that all right?
Yeah.
Okay. Cool.
Hey, Mr. Napoli, I have a question about your process for number 19, because on the formula, there's an n, like the exponent is nt. So when I did that, I did 200 divided by 365 to get the number
Okay,
of.
so how many times did we multiply this growth factor? We're multiplying this growth factor for 200 days.
Okay.
So don't get so caught up in the formula. NT is only if you're using years and you want to convert years to some other time period. But in this problem, we were not given years. We were given the number of days. When you do a growth factor, the exponent is the time period. This growth factor is per day, so the exponent's days.
Okay.
Right? Is that because if you did 200 divided by 365, that's less than 1.
Right.
Right? So is that clear? Like,
Yeah.
okay, so just
Yeah.
the exponent is the time based on the growth factor time.
Okay.
Okay? Think of it that way. It's a lot easier. All right, everybody good?
Mr. Napoli?
Uh-huh.
Zach, his connection went off and he's trying to get back in. Can you
Yes.
let him back in, please?
Okay, thank you. He's not popping up, so
Okay, I'll ask him.
Yeah, I'm not seeing him pop up, and I'm not seeing his name. I am recording this, so there's a backup plan. All right, I see him now. I got him. I just admitted him. All right. So we should be good. All right, Zach, welcome back. So you guys are going to get a little bit less homework than I normally would give. So I went ahead and I'm going to just give you PDFs of it. All right, that way you don't have to get confused with stuff. So what am I trying to do? Yeah. All right. So we're going to look at one thing. I think I'm going to skip this. This isn't that important. When we create functions, there's different ways we can create them. We can add, we can divide, we can multiply. But if we're creating what's called a composition, that's where we put one function into the other function, right? And this little circle symbol kind of means that. What it means is we're going to put the g function into the x of the x function. So we're basically going to substitute. And rather than writing it like it is here on the right, all these parentheses, it kind of overwhelms people's eyes. People just use this little circle. So this little circle does not mean multiplication. It's just a symbolic way to represent this right side. It just means we're putting the g function into the x of the f function, all right?
Mr. Napoli, you can't see
Uh-huh.
your screen.
What's that?
You can't see your screen.
Oh, it's because I'm probably not sharing it. Oh, okay. Thanks, y'all. Let me straighten that out real quick. All right, hold on. Yeah. Thanks for letting me know. I didn't realize I wasn't sharing. So this is what I was talking about. All right. So this little circle means we're going to put the g function into the f function. And on the right side here, this is what that means with a lot of parentheses. So notice the g function's going into the parentheses of the f function. So the x is being replaced by the g function. And rather than writing all that, people use this circle. Now, when we get domains of these things, we want to find the domain of the input function, so the domain of the g, and then once we get the completed composite function, we find the domain of that. Okay, so I'm going to show y'all at least one example, probably two. And so basically, we're just replacing the x in one function with the other function. And then we find the domains. Okay, so here we got a function that's rational, 1 over x plus 1. And here we got a function that's a radical function, square root of x minus 2. Now, if we find the domains of these separately, this would be x can't be negative 1. This would be x greater than or equal to 2. Now, let's say we wanted to find this composite. That means we're going to put the h into the g. And so another way of writing that would be like that. So into the g, we're going to replace that x with the square root of x minus 2. So that's called the composite function. Now, how do we get the domain? Well, we got to get two domains and then pick the more generalized domain. All right, so the domain of the input, the h, is x has got to be greater than or equal to 2. So I'll just put that right here. The domain of the composite is a combination. Not only does x got to be greater than or equal to negative 2, this cannot be negative 1, because then you would get division by 0. So this cannot be negative 1. Now, that's not going to happen because this is not plus or minus. the function we were given was not plus or minus. We didn't take the square root of both sides. This was given to us. If this was supposed to be plus or minus, it would have said right here. So therefore, this is not plus or minus, which means this cannot be -1. So the only domain that applies is this one. And so the final domain would be that. Now, what if we did this the other way around? What if we put the G in to the H? So if we wanted to find the composite of the G going into the H, again, that's what this means, this little circle, which is just another way of doing the statement of the problem without all these parentheses. Okay, so the G function's going in to the H function. Okay, so then over here, we're replacing the X in the H with 1 over X plus 1. Okay, so this goes 1 over X plus 1 minus 2. This is the composite. Now that's not simplified, but that's the composite. Okay, so now we got to get two domains. We got to get the domain of the input function, which was G, and then we got to get the domain of the composite function. Okay, the G, what was the domain of the G? Well, X can't equal -1. Okay, now what about the composite function? Well, in addition to X can't equal -1, we got to have what's under the square root greater than or equal to 0. So we got to solve that problem. Okay, so how do we do that? Well, we could add 2 to both sides, but then we're going to have a problem because of a rational function. All right, so let's go ahead and do that, see how we can handle that. So I'm adding 2. Now that's a problem because it's a rational 1 over X plus 1 we're being compared. All right, well, what if you use the reciprocal? Right, so if you had 3 over 1 greater than 2 over 1, and then you did reciprocals, then 1 over 3 is going to be less than 1 over 2. So we can solve this problem by reciprocating and then reversing the inequality. That'd probably be a lot easier. So let's go ahead and do that. Okay, so continuing over here, X plus 1 over 1 is now going to be less than or equal to 1/2. And now how much easier that is. Subtract 1. So X is less than or equal to -1/2. Now I circled 2 things. Notice that this is a little more involved with the domain. Okay? All right, and if you can think of it, notice then when X is -1/2, this becomes 1 over 2, which is 2. So we get 0 when X is -1/2. All right, so anything less than that's going to be okay. Okay, so now the final domain would be we can't equal -1, so X cannot be equal to -1. Okay? All right, that's basically about it. Anybody have anything that they need? Okay, so I'm gonna go ahead and check out of here. Again, let me know if there's anything you guys need. Shoot me an email. Okay.